Welcome to our channel. Today we're diving into the mesmerizing world of the Aurora Borealis, also known as the Northern Lights. Imagine a night sky, clear and crisp, suddenly ablaze with vibrant hues of green, blue, and purple. This extraordinary spectacle, the Aurora Borealis, has captivated mankind for millennia. Join us as we journey to the polar regions where the air crackles with energy and the heavens shimmer with this ethereal display. Get ready to discover some of the most bizarre and unique characteristics of this natural phenomenon. High above us, far beyond the familiar embrace of Earth, our sun rages and churns. It is a colossal ball of plasma, constantly releasing a stream of charged particles known as the solar wind. This solar wind, a tempest of electrons and protons, hurtles through the vast expanse of space at unimaginable speeds, a relentless force on a cosmic scale. But our planet is not defenseless against this onslaught. Protecting us is an invisible shield, a magnetic field generated deep within Earth's core. This magnetosphere deflects most of the solar wind, safeguarding life as we know it. However, the magnetosphere is not impenetrable. At the Earth's poles, the magnetic field lines converge, creating a funnel-like pathway for the solar wind to penetrate our planet's defenses. When those charged particles from the sun, funneled by the Earth's magnetic field, collide with the atoms and molecules in our atmosphere, they unleash a dazzling spectacle of light. Imagine a cosmic game of billiards, where the solar wind's energy is transferred to the oxygen and nitrogen high in our atmosphere. This energy excites the atmospheric gases, causing them to glow with otherworldly hues. The colors of the Aurora Borealis are a direct result of this celestial interaction. The altitude at which the collisions occur and the types of gas particles involved determine the specific shades we witness. It is a breathtaking display of energy transformation, a cosmic ballet choreographed by the sun and Earth's magnetic field. High above Earth, at altitudes of around 60 miles, the most common color of the auroras dances across the sky, a vibrant, almost electric green. This signature hue is the result of excited oxygen atoms. When the solar wind's energy collides with oxygen at this altitude, it causes the oxygen atoms to release that excess energy as light. The specific wavelength of light emitted corresponds to the brilliant green we see. This green is most common because oxygen is abundant at this altitude and the energy exchange required to produce it is relatively low. It's a testament to the power of the sun, even from such a vast distance. However, the aurora's palette is not limited to green. As we ascend even higher, the composition of our atmosphere changes, and with it, the colors of the auroral display. At higher altitudes, we encounter nitrogen. Energized by the solar wind, nitrogen paints the aurora with unique hues. Above 60 miles, nitrogen emits a beautiful blue. This blue appears as shimmering curtains or rays. Sometimes nitrogen produces deep crimson or purple. These colors show the energy of the solar wind. Aurora colors reflect atmospheric composition and energy, a reminder of the connections between Earth, the sun, and space. The auroras, those shimmering curtains of light, are not a phenomenon unique to our planet. Across the vast expanse of our solar system, other worlds also bear witness to these celestial displays. Jupiter, the giant of our solar system, boasts auroras far grander than our own. Its powerful magnetic field, many times stronger than Earth's, traps charged particles from the sun and its volcanic moon, Io. These trapped particles then cascade down into Jupiter's atmosphere, colliding with gases and igniting auroras that dwarf our planet in scale. They are a testament to the immense forces at play within our solar system. Even Saturn, known for its majestic rings, exhibits auroras. These auroras, while fainter than Jupiter's, are no less captivating. They offer a glimpse into the dynamic interactions between Saturn's magnetic field and the solar wind. These extraterrestrial auroras, while visually stunning, are more than just celestial fireworks. They provide valuable insights into the composition and behavior of other planets' atmospheres and magnetic fields. Scientists, by studying these auroras, are able to unravel the mysteries of distant worlds and gain a deeper understanding of the forces that shape our solar system. The discovery of auroras on other planets underscores the fact that the interplay between a planet's magnetic field and the solar wind is a fundamental process in our universe. It is a humbling thought that the same celestial dance that paints our skies with vibrant hues also occurs on worlds far beyond our own. For those who wish to witness the ethereal beauty of the Aurora Borealis, a journey to the high latitudes is in order. The northern lights, as they are often called, are most commonly observed during the winter months. The long, dark nights of winter provide the perfect canvas for these celestial displays. From late September to early April, the auroral oval, a ring-shaped region around the magnetic poles, descends to lower latitudes. This descent increases the chances of witnessing the auroras in places like Alaska, Canada, Iceland, and Scandinavia. Venturing further north, above the Arctic Circle, offers even greater opportunities to witness this natural wonder. However, predicting the exact time and location of an auroral display is a challenging task. The fickle nature of the solar wind and the Earth's magnetic field means that auroras can appear unexpectedly. Despite the unpredictable nature of the aurora, there are ways to increase your chances of witnessing this breathtaking phenomenon. Clear, dark skies away from city lights are essential for optimal viewing. Consult auroral forecasts, which use data from satellites to predict auroral activity. These forecasts can provide valuable information on the likelihood of an auroral display in a particular location. Patience is key when chasing the northern lights. Be prepared to spend hours under the night sky waiting for the elusive aurora to make an appearance. But for those who are fortunate enough to witness the Aurora Borealis in its full glory, the experience is truly unforgettable. The dancing lights shimmering across the sky leave an indelible mark on the soul. The Aurora Borealis for centuries has captivated our visual senses with its ethereal dance of light. But what about our auditory senses? Can the aurora be heard as well as seen? The answer, it seems, is a qualified yes. Though rare and often fleeting, there have been reports of auroral sounds accompanying the visual spectacle. These sounds are often described as soft crackling noises, like static electricity. Others have likened them to the rustling of silk or the gentle clapping of hands. These anecdotal accounts, often dismissed as folklore or imagination, have gained more credence in recent years. Scientists armed with sensitive recording equipment have been able to capture these elusive sounds, confirming that the aurora can indeed produce audible noises. The exact mechanism by which the aurora produces sound remains a subject of ongoing research. One theory suggests sounds are generated by electrical discharges in the upper atmosphere. These discharges could ionize the air, creating sound waves that travel to the Earth's surface. Whatever the cause, auroral sounds add mystery and intrigue to these celestial displays. The Aurora Borealis is not just a feast for the eyes, but potentially for the ears as well. The celestial ballet of the Aurora Borealis, while most commonly associated with the northern hemisphere, in the south, a mirror to this spectacle unfolds, a breathtaking phenomenon known as the Aurora Australis, or the Southern Lights. The sight of the Aurora Australis, shimmering curtains of light draped across the southern sky, is a spectacle few are ever privileged to witness. Though separated by vast distances, the northern and southern lights are inextricably linked. Imagine two dancers perfectly mirroring each other, a celestial waltz across the poles. When the Aurora Borealis flares in the north, it's mirrored by the Aurora Australis in the south. This synchronicity highlights the global nature of this phenomenon. Disturbances on the sun are felt simultaneously at both ends of our planet. Yet the northern and southern lights retain their own unique character. The Earth's magnetic field and land masses contribute to their differences. The northern lights, often over land, appear more static, while the southern lights over the ocean exhibit a fluid, wave-like motion. It's a testament to the intricate interplay between our planet and its star. The aurora's ethereal beauty has captivated humankind for millennia. These displays are connected to the heartbeat of our sun. Every 11 years, the sun goes through a solar maximum. Sunspots proliferate and coronal mass ejections become frequent. These solar storms send charged particles towards Earth, creating the most spectacular auroras. During the solar minimum, sunspots diminish and coronal mass ejections become less frequent. The solar wind weakens and auroras occur with less frequency and intensity. The night sky may seem less vibrant, the celestial dance less energetic. This ebb and flow of solar activity has influenced our planet for billions of years. Earth is part of a dynamic solar system. The sun's activity impacts our climate and the auroras that grace our skies. Understanding the solar cycle helps predict and mitigate solar impacts. The aurora is a reminder of our sun's influence, illuminating the connection between Earth and its star. For millennia, the Aurora Borealis has ignited imaginations with its ethereal dance across the night sky. Cultures wove tales of wonder and awe, myths explaining this breathtaking phenomenon. In Norse mythology, the aurora was the reflection of Valkyrie's armor. They carried fallen heroes to Valhalla, guided by the lights. The Inuit saw the aurora as ancestral spirits dancing in the heavens. The flickering lights were souls of the departed, their laughter in the wind. In Finnish folklore, the Aurora Borealis was known as Revontulet, meaning foxfires. Legend has it that a magical fox running across the snow-covered Arctic landscape created the shimmering aurora with its tail. These stories highlight the profound impact the aurora has had on the human psyche. From gods and spirits to mythical creatures, the aurora inspires a rich tapestry of beliefs. Even today, the aurora retains a sense of wonder and mystery. Its beauty continues to inspire artists, poets, and musicians. The myths may have faded, but the wonder they evoke lives on. The Aurora Borealis, a breathtaking spectacle, is more than a visual delight. It provides crucial insights into Earth's magnetosphere and space weather. Our planet is enveloped in a protective bubble, the magnetosphere. This magnetic field deflects harmful solar radiation. The sun emits charged particles, the solar wind. These particles carry the sun's magnetic field. When they collide with Earth's magnetosphere, it distorts and triggers energy changes. These changes, driven by solar storms, are reflected in the auroras. Studying auroras helps scientists understand Sun-Earth interactions. Space weather, much like its terrestrial counterpart, can have a profound impact on our technological infrastructure. Solar storms, capable of disrupting power grids and satellite communications, pose a significant threat to our increasingly interconnected world. Here again, the auroras prove invaluable. Their brilliance and movement serve as indicators of heightened solar activity, providing crucial early warnings of potential space weather events. Just as meteorologists rely on weather patterns to predict storms, space weather scientists turn to the auroras to forecast potential disruptions caused by solar activity. By understanding the dynamics of the magnetosphere and the sun's influence, scientists strive to develop better forecasting models, allowing us to prepare for and mitigate the effects of space weather on our planet. The Aurora Borealis, while a captivating spectacle, is a powerful reminder of the interconnectedness of our planet and the cosmos. Its beauty belies the immense energies at play, energies that can sometimes interfere with the very technologies we rely upon. The auroral displays we marvel at are the result of charged particles from the sun colliding with atoms in Earth's atmosphere. These collisions release energy in the form of light, creating the mesmerizing hues of the aurora. However, these charged particles can also interact with radio waves, disrupting their paths and causing interference. This interference can impact a range of technologies, from radio communications to GPS signals. Imagine a pilot navigating through the polar regions, relying on radio communications for guidance. Suddenly, the airwaves crackle with static, the signal lost amidst the auroral storm. The impact of auroral interference on GPS signals can be equally disruptive. GPS relies on precise timing signals from satellites orbiting Earth. However, the charged particles responsible for the auroras can distort these signals, leading to inaccuracies in positioning and navigation. For industries that rely on precise location data, such as aviation, shipping, and surveying, these disruptions can have significant consequences. However, scientists and engineers are constantly working on ways to mitigate the impact of auroral interference on our technologies. By studying the behavior of the auroras and developing advanced forecasting models, they aim to minimize disruptions and ensure the reliability of our communications and navigation systems. Just as we adapt to the challenges posed by terrestrial weather, we must learn to navigate the unpredictable nature of space weather, harnessing its power while minimizing its potential disruptions. And so we bid farewell to the Aurora Borealis, a celestial ballet of light and energy. From its ancient origins in myth and legend to its role in shaping our understanding of space weather, the aurora continues to captivate and inspire. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating content. Let us know in the comments if you've ever seen the Aurora Borealis and what your experience was like.